Okay, so in last session, I think we discussed the confidence interval as well as the central limit theorem and hypothesis testing, right? Means regarding the two process, I want to see the process improved or not. So on the basis of the small data, you can't conclude the thing. So you need to do the hypothesis testing. It will help you. Okay, okay, your entire population is the different from the another group or not. Today we try to discuss the next one is the ANOVA, analysis of variance. Okay, so earlier what we discussed here in the hypothesis testing, T test and as well as Z test you can apply. If your means number of data is more than 31 and the population standard deviation is available, you can go for the Z test. If population standard deviation is not available, then we can go for the T test. So that is the two tests, means two type of the tests we discuss. Now the next point is, okay, now we have the three column, like three more than three. Okay, so in that case what we need to do means like here means three variable in short. So I want to compare okay, mm, testing in ANOVA testing hypothesis will be means suppose we have the three column. So the hypothesis testing will be you can say mu1 mu1 is equal to you can write mu2 is equal to mu3 means the mean of the three column is equal or not equal that I want to test. So when we talk about the equality, it will always come into the null hypothesis. So I will write this is the suppose three column, in that case this is the null hypothesis. You can take n number of the column and you can compare okay, all are equal or are different. Okay, so that you can check. So what will be the null hypothesis here? Okay, all are not equal. It may be mu1 is not equal to mu2 and equal to mu3, and this also may be not equal. So this type of the condition. So we need to prove that all the three are equal or not equal, that we can do with the help of the ANOVA testing. Okay, so analysis of the variance is the stats technique which is used to check if the mean of two or more group are means statistically different to each other or not. That we can check, and it check the impact of the one or more factor by comparing the mean of the different sample. Means impact also you can check means both are equal or not equal. On the basis of that we can do. So now actually we try to do all this thing in the means Python, but before that what is the means in backend what the thing will means actually done, that we try to understand. Okay, so what you need to do, suppose these are the means some research institute and चलो ये वर्क कर रहा है नहीं हो here means a research institute want to determine the best diet plan for weight loss, and here total 36 is volunteer and they try to take this 12 means member from different location. So these are the three location and they taken the means a sample, or in short you can say the member, and on the basis of that these are the result you can say. Okay, so now I want to compare okay these three column are same or different, so that you can do with the help of the ANOVA, because these are the sample on the basis of this 12 number, on the basis of the 30 and even 100, these are the sample, and on the basis of that if you want to means draw the conclusion for entire population, you need to go for inferential stats. So ANOVA is the part of the inferential stats. Okay, so now what you need to do, first you need to calculate the each column mean, and after that you need to calculate the grand mean, and even in the Python only one line of the code and we will get the answer. But what is the procedure that we try to see? So on the basis of this means first calculate the mean. So this is the mean of the group you can say, or mean of the each column, and if I want to know what is the grand mean, so I will take suppose 4 column I want to compare, 6 column I want to compare, so I will take the mean of mean, that is nothing but the grand. So this is nothing but how you will get 4.5 plus 5.33 plus 7 divided by 3, that is the 5.611. Okay, so now after that what I need to do, I need to identify what is the F ratio, and that you can calculate by means sum square between the group divided by degree of freedom divided by sum square within the group divided by degree of freedom. So how it will calculate, we try to see here. First between the group, and even you can write the between the treatment. So how we can calculate, this is the sum square between the treatment. So that is nothing but here you can write xj minus x square. So what is the xj? That is the you can say this one. Xj means the mean of the column. Xj bar means that is mean. So what is the 4.5? So how you can calculate this particular thing? 4.5 minus 5.611, 5.61 square plus 5.33 minus 5.611 means the mean minus grand mean square, plus means the total 3. So you can write the third one is the 7 minus 5.6 square. So this is the divided means here what I written summation nj. So just sum, and here n means what, how many number of the sample in each group. So here 12, here also it is 12, and here also it is 12. That's it. So this is the SSB. No need to do. This is just SSB. Means the formula is summation nj. Nj means total is the 12. 12 multiplied by this bracket. Actually, I forgot that particular. Then 12 into this one. Then 12 into this one. So this is nothing but you can say sum square between the treatment between the group. Now what is the degree of freedom? So here how many total number of the column divided by minus 1. Degree of freedom is always minus 1. Means suppose what is the degree of freedom of the some list is given. So the length minus 1. That I will explain. So now here 3. Okay. So now okay, what is the degree of freedom that I try to explain? Total 3 number of the column. Just assume that the column is equal to A. Means just assume that okay, I taken the column is equal to A. So how many degree of the freedom is present? So there how I can means how many different thing I can replace on that same place. So I can replace this total is A B C, right? So A B C. If total column is 3, so what to change this particular thing? How many degree of freedom is available? Two thing I can change. A already available. Then minus 1. Means total A, B, C, 3 thing is available, and I want to know that is the one variable. Just assume that variable is equal to A column. Okay. Now at this particular column, what the other thing can be placed? B also I can put, C also I can put if it is a random variable. Okay. So A is already existing, B, C is the chance. So 2 degree of the freedom is available.
Understood. So how many variables can impact that A, which is that?
In short means column I just want to know okay what is the means most impactful column out of these 3. That is the means I just want to know. Okay, so now this is the random variable. I don't know A also will become, B also will become, C also will become. So I just there actually A is present, but how many another thing will be present? B and C. So how many other option is available in short? So if I take the A, then option will be n minus 1 always. That is the degree of freedom.
So N is 3 here basically.
N is 3 for when I talk about the group. Okay, so now n is 3. So what is the degree of freedom? Always degree of freedom is nothing but the n minus 1. So if you take the A, then what is the option? Another thing I can put. The B and C I can put. So 2 are options. So you can say degree of freedom is 2. If there A, B, C, D, in that case 3 degree of freedom. So now here degree of freedom is nothing but K minus 1 is written. So K is nothing but the 3. 3 minus 1 is equal to 2 you will get. Okay. So now here you need to calculate what is the mean square between the group. I am talking about the between the group. So what is the SSB? SSB already we calculated. This is the 12, 4.5 minus 5.611. So like that you can calculate the mean square. Means mean square between the group. So that is nothing but SSB divided by degree of freedom.
What is meant by SSB?
SSB means sum square between the group. Between the group, between the treatment. So that is the one. Sum square. This is the means you can say sum and square we are trying to do. So that's why. Here it is written sum of square. Okay. Now, if I talk about the, I want to see the what is the variance in individual treatment or in individual group. So I'm talking about the one group and what is the variance is present. So here I'm talking about what is the sum square error inside the group. Means what I told you in this 1 minute. I think here it is written now. So sum square within the group. These are the sum square between the group. So total 3 group 1, 2, 3, and there we identify sum square means between the group. Now what I'm doing, what I'm trying to do, sum square within the group. Inside the group, how much variance is present? So that you can how you can identify. Here returns x. X is nothing but first x is equal to 6. 6 minus 4 square. Then 2 minus 4 square. Then like that means first what you will do.
6 minus 4.5, right?
I'm sorry 4.5. So 6 minus 4.5 square plus 2 minus 4.5 square plus 3 minus 4.5 square. Then you will get first one into okay. So then you will get the sum square within the group. Okay. So this is the for group 1. Then what you need to do? This is summation 2 time available. So this first summation is the within the group. Then plus I will take for this one. I will take for this one. Okay, I try to do one.
I think the slide was good. It was giving the full process.
I quickly try to do one. Okay, so what I need to, what is this here written? First, I will take the 6 minus 4.5 square plus 2 minus 4.5 square plus I will take the same thing. This is for group 1.
Yes.
Then plus I will do for the group 2 the same thing. 4 minus 5.33 square plus 4 again 4 na, so 4 minus 5.33 square. And the 4 again I will do for the third column the same thing, 6 minus 7 square. So here what is written here, the first means you will talk about the single column and add all the this what is the sum square within the group. So you will get the sum square within the group. Once you got the sum square within the group, you need to calculate the degree of freedom. So here degree of freedom you need to calculate like n minus k. N is nothing but the how many number of the member present inside the group, that is the 12. Okay, the total n, I'm sorry, capital N means the all observation. Capital N is written.
36.
So 36 minus 3 is equal to 33. That is the degree of freedom. Okay, and so just try to understand what is the process and then we try to do in the Python. Okay, so once we got this 33, what I need to do, SSE, actually this is the SSE. So SSE divided by n minus k. So what the value you will get here, that you will put here and then divided by 33, then you will get the mean square error, or you can say mean square between the I'm sorry, within the group. This is the between the group and this is the inside the group. And once you get this thing, you need to identify what is the ratio of MSB divided by MSC, then you will get the F ratio. Okay, and now you will go and check that particular thing, means here it is written, you will get the F ratio, and that F ratio I will check in the F graph. It is means I'm getting in the fail to reject area or in the reject area. So this is the procedure. Even you can go through the theory, you will understand. And in Python directly we will get the probability value, and on the basis of that you can take the decision. I need to accept null hypothesis or I need to reject the null hypothesis. Okay, means what is the null hypothesis? All are equal. Mu1 is equal to mu2 is equal to mu3, and what is the alternate? That is the means not equal.
What is this?
Degree of freedom.
That's in minus 1.
Yes.
In the first case, you did 3 minus 1.
Hmm.
The second case, I understood 36, but then why did you minus 3?
So that was the number of columns.
Number of column there we need to minus.
Three, na? In the first one, we did 3 minus 1. That case, there is number of columns. No?
3 number of columns,
Three.
minus 1 column. Because
That is the degree of freedom for between the. Here he was taking those number of columns and total number of observations.
when my screen it was showing in a different area.
Hmm.
But then when he was doing it, I couldn't find it. Then
Okay.
Sharmila madam told me you will be fair.
But data में होगा ना?
हाँ in data.
Data से that
Update data में जाओगे तो
data from.
हाँ actually ये थोड़ा slow चल रहा है. हाँ आ गया अभी. So now here from data and from picture is available. So if I take the from picture and picture from clipboard, and maybe I will get now.
That right hand side it is populating.
But I copy or not copied that particular. It is populating. So okay, so now I'm getting the data. Insert anyway. So it is working in my case. So I will delete. This is not required now. Mean and all thing we will calculate that particular part. Total 12 serial number and this 3 column is available. Okay, can I share? Means I will share this Excel file. ANOVA save as. Pandas as a PD, that was we need to do. Okay. Now I will read the file. That is the ANOVA exe file, right? So that is available here. Right click. So pd dot read, and it is Excel file. So read Excel and then pass the path. Sorry, pass the path, and I will pass R here. Then maybe it will work. So now all the value I have, serial number and the 3 location, Atkins, GM, South Beach. These are the 3 location is given, and I will save this particular file as a DF. And if you call, then this is the data DF, and their total means in each group total 12 sample value is present.
Just wait for a moment. The file is ready.
Okay. You can take this desktop 3. I will start in that case on mobile. It is available. Maybe if you check desktop. Okay. So stats.f1way and pass all the 3 group. Okay, which you want to compare, and there you want to do the ANOVA testing.
So third should be south.
Okay. I'm sorry. Okay, and directly you will get this answer. Okay, here stats means this is the stats value, means 3.54. In short, you can say this value is nothing but the F ratio. Okay, and with respect to what is the P value, the P value is 0.03. Okay, so now even if you search here what is the F table, so that is available. Okay, F distribution table in the stats, it is available. Okay, so now you can see this is the alpha, and now what the value I'm getting here, alpha is nothing but you can say 0.05. Okay, and I'm getting the value that is greater or less, means alpha is nothing but the significance value, right? And here you can see this is this here always one tail will work. Okay, here no two tail and all thing. So now this is nothing but the 0.05. This particular value is the 0.05. This is nothing but the 0.05. Okay, and now what the value I'm getting here, 0.03. So that particular value I will get here somewhere, na? This is less than. So in that case, this red area is nothing but what? Or you can say that is the reject S0, and this one is the fail to reject. So here reject S0, it means what? Accept alternate. No, 0.03, that is less than 0.05. Yes. Okay, so 0.03 will be, I will get here na somewhere. So that is, this area is nothing but what? Reject S0. And this particular area is, you can say this particular area is fail to reject. So
null hypothesis.
Null hypothesis. So I'm getting here reject S0. Reject S0 means what? Accept alternate. Means these three are different. Means on the location wise also your diet is impacting. You can, that is your conclusion in short. So now what I written in the 1 minute conclusion, if calculate the F ratio is greater than the F value. So you can say that is the, they made the conclusion on the basis of the F score. Means here what they are trying to say, the F score, if I see on the basis of that also you can see, means this is the F score, suppose that is nothing but the 4.05 is 2.75, and what I'm getting F score is 3.57. So this is the 2.75, this one is where I will get the 3 point in this area. The same thing, means same thing, they try to interact, means try to give the conclusion on the basis of the F score, and I'm trying to giving the conclusion on the basis of the P score. Okay, so here fail to reject means all three are not same. Even you are giving the same diet on these three locations, but result are not same. Okay.
What is that result of determining that F1 is statistic is equal to 3.57?
So here at this particular location, what is the F value? This is the earlier their Z table. In the Z table, we try to see the Z value. Here means on the basis of the F value, they are, means the statistician made this particular table. Now here I'm getting the F value is nothing but this is the F ratio. Here means what we calculated now, all the calculation, and we will get this F ratio.
Okay.
That is nothing but the 3.5. That calculation.
So from the F ratio, the P value is calculated. Is it?
Yes.
Okay, that's a separate formula.
On the basis of the F value, you can calculate the P value with the help of the F table. So if you know degree of freedom as well as degree of freedom 1 is your is 33. Maybe it is not available here. So you will take the 33. The second one, this is for means.
So it has created that F value. It has already looked at the table.
Yes.
And then converted to P value. What we are trying to do?
Yes. The same. So this degree of freedom first wala is nothing but your number of column. So number of column is 3. Degree of freedom, this is nothing but the with respect to the your within the treatment. Okay, so within the treatment that is the 33, but 33 here not available actually. So on the basis of the table they will give. So already that table is available in the stats like T table, Z table, F table, chi table. That means that particular table convert the value into the P value. Okay, so here means this value, if you want to see at 0.05 P value, what is the value of the F ratio? That is the 2.75. Here you will get the F value is 2.75. If your value 2.75 F value, then you will get the 0.05 probability. Okay, but if my value of F is 3.57, in that case probability will be 0.03.
That can also be used for projecting or accepting.
Yes. But here I'm considering 95%. If you consider the 99%, then the means again the means acceptance and all thing will change. Means in that case it will fall into the fail to reject. Okay. Means again this is the means conclusion on the basis of this 12 data in the each group, but sometimes because of the less data their error you will get. So again there is the two type of the error, type 1 error, type 2 error. That is the theoretical part and very simple, you can go through and understand. Means if S0 is actually true, but if you reject, in that case that is a type 1 error, and the next one is the alternate hypothesis if you accept, but it is actually reject, in that case that is the type 2. So that you can go through and how you can means reduce this type 1 error, type 2 error. So there are some theories present. Means if you want to reduce the type 1 error, then we need to increase the sample size and all thing. If you means alpha beta, there are two terminology available in the stats. So type 1 error you can solve with the help of the alpha, like here alpha is nothing but the 0.05, and if you are getting the error, then I'll reduce the alpha, go for the 99%, like that you can do. Another thing is the beta is available, that is related to this sample size. So that is again means there are a lot of theoretical part. So on the basis of that you need to increase the sample size and all thing you need to. So in the chi-square test again means here what is the thing, it is means now what we discussed till now, that is for the numerical data. But how to deal with the categorical type of the data when in the two column category type of the data is present. Suppose one is the gender and one is the timing of the means some another variable. Okay, so here I taken one example, two column one. So athletes means there a particular person is the athlete or not, that is the given, and with respective smoker and non-smoker this thing is given. So how to means they both are the related or not, this both the thing are the categorical data. So both are related or not, that you can identify with the help of the chi-square test. So chi-square test is used to check the two variable which are in the form of the category, means categorical type of the data. So is there any relationship between these two variable or not, two categorical variable, or in short you can say two categorical column. Okay, so now means how to deal with the numerical data, that you can do with the help of the t-test, z-test, as well as the means hypothesis testing and the ANOVA we discussed. There again many type of the ANOVA is also present, ANOVA and all things. So that is the means more depth into the stats part, so I will not go through that much deep into the stats. So now here it is a means qualitative for check the relationship between the two qualitative variable or not, means between the two qualitative variable, that you can check with the help of the chi-square test. And now here you can say what is the alternate hypothesis and what is the means null hypothesis. So alternate here means you can say there is the relationship between the two categorical variable, and no relation means null hypothesis. That is the means here thing. Okay, so h0 means no relation and h1 means there is the relation present between the two variable. So now how to means calculation done inside the chi-square test, we try to okay, we try to do the some manual calculation. 1 minute. So here first what you need to do, you need to make, you have the two table, means one table is related to athlete, means yes and no, that type of the data is present. In second table the data is present, he is smoker and not a smoker. So now you need to make first cross table. So we try to do this particular thing by taking the some example in the Python also we try to do. So now this is the means cross table. Okay, so here athlete and non-smoker 14 and non-athlete and non-smoker is the 0 on the basis of the data. This we will get in the Python, just you need to write pd dot cross table, you will get this particular table. And now in the athlete and smoker 4 and non-athlete and the smoker is the 10. So now this is the value and this is just total. Okay, so now how to calculate this chi-square value? So this is the chi-square value related observed minus expected frequency divided by expected frequency. So how to calculate? This is your actual table. Actual table is nothing but the observed data, that is you observing, right? Now what is the expecting, and you can say expected frequency of that particular data, that you can calculate with the help of this formula. So now you have this particular table. So on the basis of that, this is the expected will calculate. So what is the thing here? The total number of the observation of the row means what is the total number of the observation of the athlete? Okay, so athlete, their total number of the observation is the 18. Huh. And there how many means number of column. So total number of the observation in the column is 14. So 18 into 14 divided by total number of the observation, entire thing, that is the 28. So you will get, this is the expected value here, that is the 9. Here's the same thing, total number of the row is the 18, total number of the column is 14 divided by total observation 28. So 9 you will get. Like that this calculation is done. So you have already observed value, now you calculated the expected value.
Non-smoker, non-athlete.
Mm-hmm.
0. No? So 10 is total. Okay.
10 is the row total.
Into total number of observations for the column.
So 10, 14,
Okay,
10 into 14 divided by 28. Okay, so this is
same, no? For in this case it is same.
In this case it is same.
In
It could be.
same. 9, 9.
In this case it is same. Okay, so now how to calculate the chi-square value? That is the summation of this particular formula. Okay, so now first observe value. What is the observed value of this particular first athlete and non-smoker? That is a 14. And what is the expected value? That is a 9. So 14 minus 9 square. That is the here written now. Observed minus expected square divided by expected. So divided by 9, you will get the 2.78. So this particular thing you need to do for all the group. Okay, so there are total 4. So you will get the 4 value. When you add all these 4 value, you will get the chi-square value. And now you will check this particular chi-square value in the chi-square distribution table. If you get this chi-square value right, means to this particular, this is the your, just assume that at 0.05. If you get in this area, then you will reject the S0. If you get this particular value here, in that case fail to reject, so accept the accept the alternate. Okay, so here in this particular case, for this particular data, I'm getting how much? 1 minute.
Again, sorry, if it goes into the one tail, then we will reject the null hypothesis, right?
When we talk about the means F test, chi test, there always one tail will be present.
Yes, but the tail, if it goes with the tail, the p value, then we will reject the null hypothesis.
Right? Yes, yes.
So p is low.
P low, null go. Like. NumPy as a NP, and here I will put the name also in the markdown chi-square test. Okay, so now if I want to feed this particular data, there 14, 4 and 0, 10, that is the table. So I will feed that table first. Then we will take the one example, and that particular example there we will take the two categorical data, and that two categorical data we will convert into the cross table, and again we try to do the same thing. Okay, so now here if again array I need to make 2D array, because here row is also present and the column is also present, and when I talk about the array, it means what? Numerical data only. Okay, so now in the first this is the in the first square, what is the value there? If I quickly go through 1 minute, 14, 4, 0, 10. Okay, so in the first table is 14 and 4. In the next what is the thing? 0 and 10. So 1 minute, what is, why I'm getting this much error? Okay, I need to pass on my so this is the actual our cross table in the example, and how to make when we get the real data, how to make this particular thing, that also I will do. Here again, how to do the chi-square test. So there is the in the stats only chi-square means okay, I need to call import there in the stats, I think sci-pi stats, and there I need to from, I'm sorry, from, I need to import the chi-square. So chi, when you write the chi and press the tab, I think chi contingency you will get. Okay.
But I have a question. When we import the entire sci-fi stats, then why will we import something within that?
Okay, in that case it is more easy, means you what the thing you need to write, if you not import, then you need to write stats dot this particular thing.
I see.
So it will be easy directly, no need to write now stats dot and all thing. You even you can write now here in the stats, you will get that particular option when you press the tab, and when you go to the chi you will get. But here now I no need to call stats again and again, directly chi contingency and you will get the answer. Okay, so now if I take this particular thing and 1 minute, chi. Okay, so now I will take the chi contingency and there I will pass my observed data. So what is the observed data? This is the data. For this particular data set, I want to do the chi-square test. So now if you see, what is the first one? This is nothing but your chi value, chi-square value, what we calculated. Okay, so here in this PPT, if I go through, that is 15.56. There may be some mistake, I don't know. So some calculation mistake will be there. Okay, but the value of the chi-square is 12.6 actually. Okay, now what is the p-value? Now the next, okay, the next one is what? The next one is the degree of freedom. That actually I forgot to explain. 1 minute. So if you want to see, so degree of freedom, how you will calculate in the chi-square test? Number of row -1, number of column -1. So there 2 minus 1, number of row when I talk about 2 row. So here 2 minus 1 is 1 and 2 minus 1 is 1. So you will get degree of freedom is 1. Okay. So now degree of freedom 1, at degree of freedom 1, and when you take the p value for your means alpha value is 0.05. In that case, means this is the value at 3.84. Means if you get more than 3.84, it will come into the reject as 0. Less than, then it will come fail to reject in that particular area. Are you getting my point?
Less than 3.8, we reject the null hypothesis. More than 3.8, we accept the alternate hypothesis.
No.
Sorry.
You means when the value is greater than 3.84, means I am in this particular area, means reject as 0.
सर एक बार ये बोर्ड पे आप बताइए नहीं p वैल्यू से बड़ा कंफ्यूजन हो रहा है बार-बार सर. It's
किसका?
a linear confusion everywhere. So p value when we say
this is the means okay, this is the graph na.
This, no null go.
So p value, p means first p, how you will decide, okay, what is the p means you will decide. So on the basis of alpha is 0.05, means 95% confidence level. Okay, so now this particular means 0.05 area, if I take this area, okay, so this p value 0.05 when you will get, when your value is 3.84 chi-square value. Okay, so now this is the one. Now what is the thing, when you calculate the probability and that probability is less than this, it means what, it will fall in this particular area, in this particular area, right? So that is nothing but the reject as 0, and this area is fail to reject as 0. Okay, so now alpha value is, you can compare with the help of alpha value, means p low null go. The next you can compare with the help of the chi-square value also, means chi-square 3.84, greater than 3.84 means it will come here, less than means it will come here. So if your value is greater than 3.84, so if I see in the analysis it is greater than 3. So it is in reject to S0, means if I go to the again PPT, where I will get the 12 here na somewhere. So that is the reject S0 wala area. 3.84, everything here start with the 0. This is the 3 point, till 3.84 I will get the fail to reject S0. After that it will go to the reject S0, where I will get the 12 here na somewhere.
Correct.
So that is the reject S0.
We will reject H0 and accept null alternate.
Accept alternate. So one way is on the basis of the that stats value, means chi-square value, f value, t value, z value, you can decide. The next on the basis of p. The p is the better, because here just you need to see p low, you can reject
the
the
difference is 0.05 p value, if you go towards right, it will keep reducing.
Yes.
In case of chi-square, it's increasing.
Yes.
That's the difference. That's why I got confused. So I asked you to explain.
So this is the universal formula. If p value is less, means reject the null.
If p value is less than 0.05, you reject null. And if p value is greater than 0.05,
then accept.
You fail to reject, which means to accept null.
Yes.
Alternate.
So here you can see 12.6 means obviously it will come into the reject as 0, means we are accepting the alternate hypothesis. And what is the alternate? Here there is the relationship between the two categorical variable. So what will be the conclusion for chi-square test? When I talk about the chi-square test, there what is the S0? No relation. S0 means no relation. And what is the H1? There is the relation. means between the these two variable their relation is present. That is your conclusion. Okay. And one more thing what we can do here, we can save this particular value. If you okay, so first one is the chi-score, so I will write here chi-score. First one is the chi-score, right? I will write the chi-score score, and the next one I will write equal to, and there I will write all the four things. The next is the p-value, the next one is degree of freedom, okay, and this one is the expected frequency what we calculated, 9955. We calculated na in the ppt means manually also. Expected, this one 9955, expected, yes. So this is the expected frequency. Hmm? So these four equal to this one. So you will get now, if you want to see individually, okay, what is the chi-score? Can you show me? So it will show the chi-score. Okay. If you want to see all the four things, now you can see. Means it is it's more suitable. Now you can see. Okay, sometime maybe you will confuse now. Okay, which number is indicating to which particular value? Means the first one is the chi-score, the next one is the p-value, third one is the df, degree of freedom, and fourth one is the expected frequency. Okay. So now we try to take one example. Okay. So okay, so first from Seaborn we will take that TIFF wala file, and there two category type of the data is available, so that we will take. So here import Seaborn as a SNS, and then load data set SNS dot load data set, and there if I pass the tips, then this is the data, and here if I want to see is there any relationship between the what we can identify day. Okay, so first we try to see is there any relation between the day and time, that I try to check. Okay, both are the categorical type of the thing, and in these two variable is there any relation present or not present. So first you need to define na, so you need to call import Seaborn as a SNS. Okay, so here I want to see the relationship between the day and time. So and chi-square you can apply when the variable present in the form of the categorical data, then only you can apply. Okay, so now what I can do, okay, first I need to make that cross table, so that I try to make. Okay, so in cross table, what with the help of the PD we can make. So PD dot, and when you press the tab, so cross tab you will get. Okay, so when you type the C and press tab, you will get the cross tab. Okay, so in this is nothing but the cross table, and first I need to assign this particular thing as a one variable. So I will assign this particular thing as a data. Means if I do the assignment now inside the data, what the thing is present, that also you can see inside the data, this all the thing is present. So I'm assigning as a one variable, so I can utilize this particular data again. So now inside the data, the first day and time I want to see. Okay, so data, and here I will call the day. The next one, what is the means cross table you want to make between two variables, so that I will pass. First one is the data day, and the next one is the data time. Okay, so this is the data day and time. Okay, so this is the cross table. Now you can see the cross table and their time and day. So time, there two type of the thing is present, that is the lunch and dinner. And when you see the day, their total 1 2 3 4 4 categories present inside the data. Okay, so now we try to, okay, so I will save this one as a for chi test data, chi test, or what I can write, chi test observe. This is the observe data, right? Okay, so now you can do the chi-square test with the help of the chi and chi contingency, and there pass this observed data, you will get the answer. So when I pass inside this particular function, you will get the answer. And what is the value of the chi? That is the 217. I'm sorry, the first one is I think okay, the first one is the your chi-square value, so that is the 217. The next one you are getting the p value, that is the 8.45 into 10 raised to minus 47. So you can say that strongly, you can say it is reject as 0, and what reject as 0 means accept, and you can say that relation present between these two variable. Okay, and what is the degree of freedom? That is 3. Why 3? Because when I talk about the column, there only two column is present. Where is the, okay, if I see this particular thing, you can see so only two column present, so that is the 1 into 4 minus 1 3. So that's why I'm getting the degree of freedom is equal to 3, and this is the your expected value calculation. Any doubt?
So can you just quickly go through how you got 3?
Okay, so what is the degree of freedom? If I go to the again PPT, here you can see the degree of freedom. Degree of freedom is nothing but the number of row minus 1 into number of column minus 1. Okay, so in my case, number of column is 2, so that is the 1, and here number of row is 4, so 3 into 1 is 3. Okay, so even you can compare now the different thing. Okay, so now if I pass instead of these, what I can pass the another data, just I want to pass observed, and there I will pass dash 1 any variable name, just I try to give
So P value is high, so alternate hypothesis, right?
p high. P value high means accepted. Fail to reject. Fail to reject as 0.
Fail to reject means obviously accept.
But you can't say accepted in the
Fail
stats.
to reject.
Just you need to say fail to. Critical value this one, na?
So 217 is only the critical value.
No, no. Critical. Critical value is on the basis of alpha you will get, na? This is the critical value. 1 minute. So if I go to the PPT again, on the basis of alpha you will get the critical value. So here you need to check the inside the table. You need to check, okay, degree of freedom is 3. Then what is the critical? 7.81. If my value chi-square value is greater than 7.81, then it will come into the this reject as 0 area.
Correct. Correct. This side, right?
Yes. Okay, so I just change now. If I pass the, okay, what we can compare now, smoker and time. If I pass, let me check. This is the observed. If I pass 1, and now if I check the chi contingency, and there I will pass this chi dash 1 means this data. Now you can see here p value is what? P value you are getting the 0.4. It means fail to reject, means there is no relation between these two variables. Now you can say there is no relation between the smoker and time, and there is the obvious point, smoker and time, there means obviously no relation. So like that, in your research, if some categorical data related column present, you can compare and you can give the conclusion on the basis of the stats. These are the conclusion. Okay, so here no relation. Okay, so both the thing we got now. Here
Sorry, again, simple questions. I keep forgetting. Where do we use Anderson? Where we use ANOVA? Where do we use Clipchamp test?
Like here in this tip I have two column, na? Categorical type of the column. If categorical type of the column, and now I want to see if this two category column has any relation or not. So there you need to use the chi-square test. For categorical type of the data, you need to use chi-square test. For numerical data, ANOVA, Z test, E test.
I see.
Because here the value is not numeric, na? There it is written smoker yes and no, and as well as the time.
Qualitative.
Yes, qualitative.
Right, that's quantitative. This is qualitative.
So that's why I mentioned in the PPT also in the first slide.
I mentioned the measures.
So that is for most of
Qualitative.
Qualitative on this method.
Yes.
This two qualitative variable for that actually this particular.
Because we will have to look.
Okay, so chi-square done.
So इसमें crawlback alpha नहीं है.
Yeah. Okay, so regression means suppose now you want to make the relation. This is the y means your in short dependent variable, and that you want to predict on the basis of some independent variable. So now you try to identify relation, y ka relation with x1, x2, x3, x4. Okay, so now we already discussed some admission related data, and there on the basis, suppose just assume that x1 is the TOEFL score, this is the GMAT score, this is the 12th percentage, and like that some independent variable is present. On the basis of that you want to predict he will get the admission or not. This is just one example. Like that you can predict anything. Means you want to predict what is the chance he will buy the credit card, not buy the credit card, he will go for the insurance policy or not go for the insurance policy. So it will change with respect to the context. Okay, so now this particular thing, now you try to predict this particular y. So this y is the continuous or it is a categorical type of the data. That is the again point. Means you want to predict he will buy the credit card, means yes and no. You just want to know this particular thing, yes and no type of the thing. Okay, so it will come into the classification. Now this is the classification, and it is a continuous, like on the basis of the experience, means these are the independent variable like experience, age, as well as the you can say a skill set. So these are the some
Like if we say like a Likert scale thing, 1 to 10 to 8 or something. That would be what you're talking?
no,
Your demographical data.
like here
Data which is what do you call
Like
it?
age.
I want to predict the salary. Okay, what salary I need to give. Okay, so that is the y. Okay, so this is the continuous. Okay, so now on what basis you will decide? You will pass here one data x1, that is the age. The next you will pass the x2, that is the experience. The x3 means you will pass the qualification. So these are the independent variable. On the basis of that, you try to predict the salary, which is continuous. So if continuous, then it is a regression part. If it is a categorical type, then it is a classification. Okay. So now it is a regression, means what you try to predict y value, that is a continuous, and in short you can say this very simple equation is y is equal to mx plus c. If x is the independent variable and y is the dependent variable, you can predict with the help of this particular equation. Y is equal to mx plus c. If x only means it is a single variable dependent, but it is means generally it is not single variable. So you can write in the linear regression what is the equation, y is equal to m1 x1 m2 x2 m3 x3 dash 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 plus c. C is the intersection at y axis. Maybe you means go through the mathematics, then maybe you know. Huh. So this is the means regression. Regression means you, in short you can say I want to make the one equation and that equation give the output in the form of the continuous data. So that is the regression. If I make the one equation and that will give me the output in the form of the categorical thing, then it is a classification.
So can you explain quickly what is MNC?
M and C, y is equal to mx plus c, that is the straight line equation.
What is M and what is C?
Okay, so here I try to make one interpretation.
Sorry for asking so many basic
No,
questions.
no, okay. So now
There's another formula also for regression, like which one slope and the intersection A and B.
that only I will try to do. So now x is just assume that this is the experience,
Okay.
and on the basis of that I want to predict the salary.
Right.
So what I will do on the basis of the historical data, I will make the scatter graph between the x and y.
Okay.
So at this point you are getting, okay,
Okay.
some point you are getting.
Okay.
Now what you will do, you will make the best fit line. Best fit line you try to draw, so that will pass near to the all point, and this is the straight line equation. So you can say what is the equation you can represent in the mathematics, y is equal to mx plus c.
Okay.
Okay, so now what is the m? M is the slope of this particular line. What is the c? Intersection at y axis. So this particular value is the c, and what is the slope? That is nothing but the m.
And some you
Is
will call
equal.
A or B. So some places it's called A and B also. That's also fine. So the formula.
In A B,
basically
some
intersection B is the
somewhere they will write beta 0 plus beta 1 x. So that is just it. Means you can
It's the
change.
same thing. Slope and the
Same.
intersection.
Even in the matrix form they will write y is equal to w transpose x. This type of thing. Also.
M is basically the slope and C is the intersection. The slope will be what, some kind of a degree?
This is the slope, means incline, means how much in the degree in short.
Yes.
It's
Huh.
45 degree, so you put it 45.
Yes.
So it is a means 45 means 10 45. In 10 actually it will consider the slope. 10 theta.
Yeah.
Means 10 theta means what? Y by x. So I will not go that much deep. Just try to see. Means in the Python, 1 and 2 line only we need to write. We will get that from the GitHub. Then no need to download now. So this data we try to see. The means when you pass the advertising.csv GitHub now, then you will get the advertising.csv and their TV, radio, newspaper, and sales. These are the thing is given. Means how much a particular company spend on the TV advertisement, on the radio advertisement, and on the newspaper advertisement. And on the basis of that, they try to collect the data of the sales of that particular product. Okay. So everyone got this particular thing?
So I have to go to do exactly what you did.
Yes. Then no need to download directly. We will pass the GitHub link. When you click, we will 1 minute. Now this is your data. Means everyone got this data. Just click on raw. Click on raw.
मेरा तो CSV टाइप दिख रहा है. तो मेरा खुली. Why my website
होगा.
तो मेरा समीर
So now you will get the data in this format. Okay. So now raw.
data मेरे data से अलग क्यों दिखता है?
Same ही रहेगा.
मेरा क्या और है? मेरा कुछ और है.
क्या है?
आपका कम डेटा मेरा कुछ अलग ही डेटा है.
तो आपने ज्यादा वाला कुछ क्लिक किया है. 1 मिनट. ये वाला क्लिक किया आपने डेटा एडवर्टाइजमेंट.
256 एक मिनट.
नहीं, the second one. Only 3 column.
तो वही किया था देखिए.
When you click now.
Okay, second one date.
Okay, after clicking, are you able to go inside?
All that is possible. I just click नहीं आ रहा है. हां यहाँ तक आया. IDTV newspaper sales. मैं तो पहुंच गई.
Yeah. ना. Then click on raw.
So why are not able?
Raw data here.
Download raw file.
No. Just click on raw. Okay. So now this link you will get. Okay, raw.github. Just copy this particular link. Okay. I will. So here pd.read and csv and pass that particular link inside the inverted comma. You will get that data directly. No need to. Sorry. So what we did first, import the data df. There I want to consider only TV wala data as a independent variable. So now this is the TV wala data. Okay. So now you have x. Okay, x means independent variable. Now I want to create the y. So how to create the y? The same thing you can do. Say df, and there inside this df I want to pass means what is the sales. So sales.
So we will say y.
You can say the y, but let me check. Okay, if I pass the sales, sorry. This is the sales data. Okay, so this why okay, why I'm taking the double this bracket for the x. In x you need to take the double bracket because x there possible, x will be x1, x2, x3, multiple column also possible. Okay, so that's why you need to take that particular thing as a, means you can say the double bracket or you can say the data frame in the tabular format. Here you can take one square, then it will work because y always will be the one. You want to predict only, means in the linear regression y is only one, so you need to pass df sale, okay, in single square bracket. Now okay, so now I will call the this linear regression, and that is available for means generally all the machine learning related tasks you can do with the help of the sklearn. That is the one library available inside the Python. Okay, so we will call that particular library from sklearn. Okay, and that also means maybe by default available inside your system. If it is not available, then we will import linear model, and then I will import linear regression. Okay, मैं इधर कर
नहीं नहीं आपका network
यही ना नेटवर्क
नहीं what you're this thing ना what you're sharing I'm using your network
हम
what is it
it is a college network
college
college Wi-Fi.
College network has been converted to hotspot for you.
हाँ
अच्छा okay
college
so
network.
mine is not working mine is Jio just
No, it is a college network.
देखो अभी वो आ रहा है वो टैब से दिख रहा है फटाफट
हो रहा है ना, हाँ वो नेट का स्पीड रहा तो अच्छे से हो जाता. Okay, so now from sklearn linear model import linear regression, and now okay, so why we are doing all this thing, because I don't want to write this sklearn dot linear model dot linear regression. That's why I'm importing the linear regression, and this linear regression, again this linear regression function I will save as a linear, you can write any name, so I will write the linear is equal to, I will pass this particular function. This is the one function. Okay, so I'm calling linear is equal to linear regression. And now inside this linear regression, what the thing you need to do, you need to pass the x and y. Okay, so if I pass the x and y data, on the basis of that it will calculate the m and c value, and once you got the m and c value, you can calculate, means you can predict anything, means just pass x value, you will get the y value. Okay, so now what I need to do, linear, if I pass the linear, okay, and dot and press the tab, you will get the fit, and then pass the x and y. You have x and y both the variable. If I pass y is not defined, y already I think, okay, I not define, this is the y now, I will define now. So now linear regression is prepared. Okay, so how to use and what is the m value, what is the c value, that also we will see. But now this is a linear dot fit x and y. Okay,
yes
okay, so now what is the m value and what is the c value that I want to see in this linear. Okay, so when I say okay, so this is the linear, inside the linear, okay, when you press the tab, okay, and I want to see in this side the linear, what is the intercept means intercept at a y axis, that is the c value. So what is the c value, that is c value is 7.03. Okay, the next is linear, and inside the linear I want to see the coefficient, so coef, I think even you press the tab you will get the answer. The coefficient is nothing but the m value. So now what is your equation, if I open okay, so now if I want to predict, okay, suppose $45 I want to spend. Okay, so now this is the linear, what is the model name, linear, and there is the predict option is available. When you press the p and press the tab, you will get the predict option, and inside that you need to pass the value, but value you need to pass as a 2-dimension data, means okay, so now I will pass as a 45, you will get the output, that is the 9.17. This is the warning, you can ignore and you can write how to ignore the warning, that already. So what is the prediction, 9.17, even you do the manual calculation, you will get the same thing, 9.17. Double square bracket is it.
What is this 45?
45x value, x means how much you spend on the TV advertisement.
Okay.
Then y value, what is the y, means prediction is the 9.17.
Then go back a little up
Hmm.
I'm not sure except I got coefficient is there why can I not get what is this last
1 minute. Okay, I stop. Okay, so this is the prediction. One more thing is like that, this data, on the basis of this data you train and you made your model. Okay, so maybe there by chance you are getting this particular accuracy, maybe there, means by chance you will get this particular accuracy. So what you need to do, the next step, means the methodology is like that, you need to divide entire data set into the two part. One part I will use for making a model, so that is nothing but the training data, and one I will use to check the accuracy and evaluation purpose of that particular model, so that is the test data. So you need to divide the data into the two parts, so that we will do slowly.
yeah so then just thinking aloud so when we collect data or whatever data we are checking that reliability validity of our material or our questionnaire then we start with the crawlback alpha whatever then we move to get chi-square and then whatever then we have this relationship in that then we go forward and always we tweak our system and I don't have it in my brain. Upload file. Upload, retrieve. Archive may not need it.
Okay, so this now what is the thing? Okay, because we pass already this data
Yeah.
inside my model making process,
Yeah.
and on the basis of the same data, I try to calculate the accuracy of the model. So that is not an accurate way. What you need to do, you need to divide the data into the two things: train and test. Test data I will utilize for the evaluation purpose. So that we will do when we take the some
So
case study.
basically, what you're saying is, from a theoretical point of view, so that your data is.
So is that split up?
Split we need to do.
So
We will,
you're right. You're right. You're right. Split half technique is what you're talking. Correct.
but we will not discuss though, that
No, no,
part.
no.
Test retest.
Haan,
No,
yes.
we're just talking about concept.
There even you need to check when you take that.
Yeah, test reset.
Yes. Yes.
So in my PIT, we check this Cronbach alpha and all thing for the reliability of the data.
Yes, yes.
So that also you need to do.
Yes.
Okay. So now one more thing. Even you divide the data means
Sir, you can the graph and show us plot the graph. In this, no, it doesn't plot.
it will plot. Okay, I need to check that particular part. It will plot. I will do that in the next class.
Okay.
There is a different maybe library.
Yeah,
I will
just to
check.
see what it looks like.
Okay, we will do that part. And one more thing, even when you divide this data into the train and test, so there means there again you need to see that test data means that is the by chance means you got the data in test that give the good accuracy. There again one case, so that's why you need to do the cross validation. So that is again we need to do. So there are a lot of things actually.
No, no,
Otherwise, your examiner will ask.
Then what test
Many-
you do? What reliability test? What is your obviously you have to do?
From what I'm understanding.
Part-
लगा पकड़.
Okay, so now okay.
वही है.
Okay, so now again I need to define x again, right? So this is the df, and now in df I will take the one is the means in the double square I need to pass. First one is the TV, the next one I will pass, that is the radio, the next one I will pass the newspaper. Okay, so these three variable I will pass. In these three means when I pass these three variable means the equation will be y is equal to m1 x1 plus m2 x2 plus m3 x3 plus c. That is the equation. And now this is more than 2 dimensions, so I can't visualize means by some graph. Okay, so now df, and this is the thing, and now if I call, you can see all the three value is present, and now I will assign this particular thing to x. So now my x is new and there are three variable is present. Okay, and earlier only one. Now I have x, I have y, so I will make the linear regression. Okay, so now how to make the linear regression? You know the linear. Okay, linear regression. If I call, okay, I will make the linear regression. 1 minute, sorry. So linear regression, and here I will write multivariate linear regression because here multiple variable. So multivariate linear regression actually it is known as a MLR. And if I call now, this is the MLR, and in this MLR, okay, so you can give any name, but I just pass the multilinear regression, and now here I will pass the fit, and what data I need to pass x and y. When I pass x and y, now you will get the linear regression. In short, that is the y is equal to m1 x1 plus m2 x2 plus m3 x3 plus c. Okay, so now in this MLR, I want to see what is the interception. Intercept, that is nothing but the m value. I'm sorry, that is nothing but the c value. And when I talk about the m value, you will get the three means m1, m2, m3, right? So now if I pass the COEF coefficient, and you will get the three value. So what is the equation here for this linear regression? The equation will be y is equal to means this one means m1 x1 plus m2 x2 plus m3 x3 plus c. So this x1 is the expenditure on the TV, x2 is the expenditure on the radio, and x3 is the expenditure on the newspaper. M1 is nothing but this one, M2, M3, okay, and this value is nothing but the 2.93C. Now it shows the importance also. Here you can see 0.04, 0.18, it is good. Now here 0.0010 means the importance of the third variable is minimum. You can say like that, okay. So now even you can remove that type of the thing because importance is less now. Even when you make the equation, what is the contribution of this particular thing, this particular thing is minimum because I'm multiplying that particular thing with 0.00, so it is means not impacting that much. And even you can say the newspaper related variable is not significant for the sales, you can say like that. Okay, so
I'm getting an error. MLR not defined.
you need to define the MLR. So
MLR equals to linear regression.
I will show.
This one.
MLR is defined.
Sorry, just give me a second. Okay, thank you.
Okay, so now this is the next equation, and let's check what is the accuracy of this MLR. So now obviously you will get the more accuracy because now three variable, and here two are the means important variable. Even we taken the earlier TV, but if you see the radio wala is more important, significant. So now if I pass the score and if I pass the X and Y, so you can check the accuracy is the approx 90%.
Yes.
Okay. But again, I'm passing the data because we are in the initial stage, so it is okay. But we can't say the accuracy is the 89% because already when we train, we pass the same data. And on the basis of that means we taught the same means we taught one question, the same question we given into the exam, and on the basis of that we evaluate the performance of the student. So that is not good.
Correct.
You need.
There are indicators of improvement in learning.
Huh.
It's just that repetition of questions and they're already exposed to it, their responses.
Yes, yes. So that's why maybe we are getting the good accuracy.
Yeah,
so we
yeah,
will do means how to split the data into the two parts. Even that test means by chance we are getting the data in the test that are giving me the good accuracy. That is by chance, or actually it is giving me the good accuracy. That's why we need to do the cross validation and all.
You're finding whether that okay. Got
Yes.
it.
Okay. So what I think. Okay. So one more thing. What we can do. Okay. I want to save this particular file. Okay. I want to use again the same model when it is required. So how I can save? So that we try to do, or 10 minutes to we try to do that. Okay, so now how to save this particular model? Okay, so this is the model, MLR is the model, and I want to save this particular model in my system. Okay, so what I will write, first you can save the model with the help of the means pickle, that is the one library inside your Python. With the help of that you can save the model. So this is the import pickle you need to do. So with the help of the pickle you can save the model, because no need to do again entire thing, entire calculation and all. Okay, so now
Sir, typical what we do to save the model.
yes, we can save the model.
Go on over there, put a hashtag and just put that.
Hmm.
Import pickle to save the model.
Okay, so now what model I want to save? So suppose pickle,
Where does it save, sir? This file.
it will save in your PWD.
In where you directly.
But I still be not saved now. We will
No,
save.
I'm just putting a comment. By default, we have given it the
By default, it will go in PW.
In our case, it goes to the.
In my case, it will be in the Python class. So pickle, and I need to pass now dump, means I want to dump this particular model inside my local system. And now what is the name of the model? That is the MLR, and where you want to save. So I will write here open. Okay, and in open there I will write the name. What the name you want to give. So I will write this model name. Okay, MLR means what the file name you require that you need to pass. So I will write anything. Okay, so this is the MLR dot pkl. This is the extension of the model, pkl dot sav dot h5. There are many extensions, so you can pass the pkl. And one more thing, even save now. Okay, and here means this is the one file it will open. Okay, inside your pwd, and there actually I want to write something, so that's why you need to pass writing base, means wb. Now run. So now this file is saved as a mlr.pickle. So if I go to the h and here mlr.pickle is available in my pwd. In your pwd means maybe means where you are running that Jupyter notebook, it will be available. Okay, in that particular location.
Okay.
Where are you getting it in Colab?
That's what I'm also looking.
In Colab, their content in the file you will get.
Means.
Right side, their folder is available. Click on the folder. There you will get.
It's come. It's come. In the on the right side now.
How to call this particular model? Okay, so now I'm starting any new Jupyter notebook and I directly want to use that particular thing. So I will write pickle. Miss, if I write the pickle, then I want to load the model. Okay, so you can write the load. Okay, so load and pass what you want to load, means what the file you want to import here. So the name of the file is you need to open that particular file again. Open and write mlr dot pickle, and there I just want to read that particular file. So read base. So now linear regression is done. You can give any name, even you can write lr any name, and you can start the prediction and all thing now. So lr, and now if I do lr dot predict, and here if I pass the multiple value like 45,
Sorry. Sir, so you said WB is writing base and RB is read base.
Read base, writing base, like that. Here I'm dump means I'm writing on that particular file. Now here so just I'm reading, so that's why. So one more thing, even the data is increased 10 lakh 20 lakh, your file always will be in the KB, because it will save only three value like M and C. Okay, so if more data, M and C will be more precise. Less data, M and C will be less precise. That's it. Okay, so now this three spend means 45 I will spend on the TV, $34 I will spend on the radio, one I will spend on the newspaper. Then what will be the output? So 11.40 will be the same. So that, like that you can predict. Even this two line only now you can write in any Python notebook, it will work, because your model is already saved. So no need to do again sklearn call and all things. No need to do. Means the model making process is already done, and model you have, you can directly utilize with the help of the pickle.
This 45, 34 one is newspaper, TV and all that.
Yes, first one TV, the next one is the radio, third one is the newspaper. So all the three value I pass.
So it shows 11. So the accuracy is only 11%.
No. This is the value, means your sale will be $11.40 with the accuracy of 89%. We already calculated the accuracy.
Okay, of it.
Yes. Score means accuracy. This is the prediction on the basis of that model.
Got it. score is accuracy and prediction is y.
Yes. So again, this is the means how you can make the linear regression model. But
Sorry, the predict is not defined for me. Why is that? Why am I getting that?
so
Predict your आपने S किया, predict
नहीं नहीं this LR you done.
have you defined LR is to pickle
Pickle not load or open and yeah, I've done all that.
It
I didn't
work?
get any
It is
error.
working?
I didn't get any error.
So
See, you want that
LR equals
okay, so
dot
now
comma will dot equal. Dot comma दिखता है. Sorry, dot comma still distinct, but equal comma नहीं.
okay, so this is the means how to make the means linear regression. Even we will means discuss in detail in the next session by taking the some case study. And one more thing means before doing means making this particular model, you need to check the missing value and all things, because here missing value is not present. And one more thing, domain knowledge is required. Means actually this three thing is impacting to the sale or not.
Correct.
You can pass means anything, it will give the some result, but
Yeah, but
it
you
is
need to have the knowledge
so
expertise.
domain expert is required, as well as you need to do the some analysis like is there correlation present or not. Means what we did in the earlier, there really correlation present or not. There means sometime non-linearity also present inside the data, so that also you need to check. So there are many things you need to do before going for the model making process. Okay, so even there are many things like multicollinearity you need to check. Okay, in my data multicollinearity present or not. It means when we make the model, what is the requirement? Always the relation between the this means suppose I assuming x1, x2, x3, x4, these are the independent variables. So relation between these independent variable is always required weak. Okay, and relation of this particular independent variable with y is required strong. So that is the criteria. Okay, if there is the relation between x1 and x2, in that case in that particular case you will not get the right coefficient value of m1, m2 and all things, because these are the dependent. So that is the means assumption when you make the linear regression, the means independent variable is means weakly correlated.
To each other.
Yes,
Correct.
because otherwise there is no use now when you pass through strongly correlated data.
Yeah.
It means you are just changing the unit and that type of the thing.
Correct. No, I can understand.
So that's means that thing you need to take care, because Python will give the end of the day results, but you need to take care all this.
बेटा आज भी government expertise हमारे पास भी रहेगा.
Okay, so I stop here. Huh?
Yes, sir. Thank you.
Thanks.